In today's video lesson, we're going to review acids and bases from our prior knowledge. So acids have a lot of properties in common. So an acid produces hydrogen ions or protons in the form of hydronium ions in water. They taste sour. Now, we wouldn't want to taste every acid that we come across, but like the ones that are edible, lemon juice, vinegar, citrus, they're all sour tasting. We can infer that all acids are sour tasting, but I don't recommend tasting them. Acids corrode metals. They are electrolytes, so they conduct electricity because they dissociate into ions. They react with bases to produce a salt and water in a neutralization reaction. And acids have a pH of less than 7, so anything lower than 7. And they turn blue litmus paper red. So one way of helping you remember is blue to red is acid. Kind of rhymes. Now, bases produce hydroxide ions when dissolved in water, and they taste bitter or chalky. If you've ever had, baking soda plain, it's very bitter tasting. Or if you've ever had the misfortune of eating soap, same thing, it's bitter tasting. So bases are bitter. They also are electrolytes because they too dissociate into ions, and that allows the solution to conduct electricity. Bases feel soapy or slippery, so that's why soap does such a good job, because it is slippery. If you've ever had bleach on your hands, if you've ever spilt a base on your hands will feel very smooth and slippery, so that helps you identify that you maybe need to get that off your skin. Bases react with acids to form salt and water in neutralization reactions, and bases have pHs of greater than 7. And they turn red litmus paper blue, so I always think blue for base, and that helps me remember how litmus changes in the presence of base. Now we'll review the pH scale. So the pH scale is a way of expressing the strength of acids and bases, and we use this scale because if we were just using the molar concentration of hydrogen or hydroxide ions, we would be using really small negative powers of 10, which is hard to manipulate. So instead, we use a logarithmic scale to help us use numbers that are much more easy to use. So acids, have really low pH, so pH of 1 versus 2. That means that the pH or the concentration of the acid is 10 times stronger or higher. So we'll just move from there and talk about how we can determine pH. So we calculate pH by taking the negative log of the concentration of hydrogen ions or protons. So to find the first example, the pH of a 0.15 moles per liter solution of hydrogen chloride or hydrochloric acid, remember, pH equals negative log the concentration of hydrogen ions. So it's going to be equal to negative log 0.15. And that is equal to negative 0.0 or 0.82. Or just when you cancel out those two negatives, the pH is 0.82. In our second example, we're trying to find the pH of a 3.00 times 10 to the power of negative 7 moles per liter solution of nitric acid or HNO3. So pH again is equal to negative log of 3 times 10 to the power of negative 7. And that is equal to 6.52. So that's the pH for the second one.